What's up, Algebra 1? It's Mr. Ford here with a homework tutorial. This is 436 through 441, which I'm going to call Due Wednesday, since we will have a quiz day tomorrow, and we'll have a little bit extra time to work on it. I'm getting ahead of the game a little bit here. So anyway, for this first question, we're actually going to need to describe association in a scatter plot, and for that, we're actually going to need to go back in time a little bit and look at this math notes box right here. Which we'll talk about a little bit in class tomorrow. When it comes to describing association, really there are going to be three words you're going to choose from. The first is going to be linear or nonlinear, and so that is going to determine if it's making a straight line or not a straight line. The next is going to, well, and here are some examples down below. Linear, so you can see this kind of the straight line-ish thing going on here. Nonlinear is going to be more of a curve, so you see kind of a swoopy swoop like that. And then again, you have a linear association right there. Now, the other word, another word that we're looking at, you've seen it already here, is negative or positive. Negative and positive. Negative is going down, positive is going up. And then finally, you've got strength, which has three words you can choose from: strong, moderate, or weak. And you can see the difference here. The strong connection has the lines very, very closely around the line. A moderate, they're scattered, but there's still a decent line there. And you have weak, which is, this line is a guess. There's almost no connection at all. So when it comes down to it, you're going to choose the following combination of things. You need to choose positive or negative. You need to choose one from that column. Linear or nonlinear. You got to choose one of those two words, and strong, moderate, or weak. You're going to choose one of those three words, basically. So let's go down to this problem and see what we're looking at right here. We're going to describe the association here. Now, I think this is nonlinear. I think you can see a pretty strong curve going through that. In fact, I would call this a strong, positive, non-linear association. Honestly, there's a lot of leeway here with these. There's a lot of, you can flow. If you told me it was negative, I'd mark it wrong. But if you told me it was linear, I'd believe you. I would say it's a weak linear, but hey. Okay, let's go do some math. 437. We're going to solve these equations for one variable. Here we go. Let's start by combining like terms here. 8a plus a is 9a minus 3. Then you got 4a minus 3. If you subtract the 4a from both sides, you can get 5a minus 3 equals negative 3. If you add the 3 over, an interesting thing happens in that the 3's actually all cancel out. This does not mean no solution, though. This is a common misconception. 5a equals 0 has an answer, and it happens when a equals 0. If you divide by 5 on both sides, you'll see that answer pop right out at you. 0 divided by 5 is 0. Question B. For this question, you might remember a question just like this on the Chapter 3 test. We're going to be multiplying a bunch of stuff together. We got to do some generic rectangles for this. Now, I'll do a generic rectangle for the first one, just in case, to remind you how to do that. M plus 3 here. You'll have an m squared, a 3m, a 2m, and a 6 when you do the multiplication. So that's an m squared plus 5m plus 6 when you combine the like terms together. Over on the right side, you know what? I'll be nice and do it over here. You'll have an m plus 2 and an m minus 2. This is an interesting one because you get m squared, you get a negative 2m and a positive 2m and a negative 4. And what happens is the negative 2m and the positive 2m actually cancel out. So you get m squared minus 4 and nothing else. Which actually makes this problem really easy to solve, because once you get here, you can just ignore the m squareds on both sides and cancel them out. And you got 5m plus 6 equals negative 4. Subtract the 6 from both sides, you get 5m equals negative 10. And when you divide by 5, you get m equals negative 2 for the answer. Which I think makes both sides 0 if you plug it in. Yeah, if you plug negative 2 in there and there, you get a 0 for this whole thing and this whole thing, and if you multiply it by 0, you get 0. So Question C has a fraction in it. Oh no, actually really easy. Start by subtracting 1 from both sides. These cancel out. You get x over 2 equals 5. And now you want to multiply by 2 to cancel out the fraction. I mean, that's x divided by 2, so you want to multiply. These cancel out. You get x equals 10. You're good to go. Question D, again, this is a lot like the question up above, only a lot of that work's been done for us. You can ignore the t squared term since there's 1 on both sides. Doesn't really do anything. In fact, this problem is actually really easy afterwards. 4t minus 2 equals 6. Add the 2 to both sides and you get 4t equals 8. Divide the 4 on both sides and you get t equals 2, and that's the end of that problem also. T equals 2. Pretty cool. Just ignore those t squareds. Let's look at the fabulous footballers in problem 4. Oh no, my thing messed up again. There it goes. Gotta do this a lot. I was zooming in too aggressively. It happens when I zoom in and zoom out too much. Fabulous footballers scored an incredible 55 points at last night's game. Interestingly, the number of field goals was 1 more than twice the number of touchdowns. Okay, here we go. And the fabulous footballers earned 7 points for each touchdown and 3 for each field goal. We're ignoring the whole extra point thing, I guess, in this problem. Now, what we're looking for, we got a multiple choice thing going on here. Let's see. We're going to assume that T is the number of touchdowns and F is the number of field goals. So let's start by translating these sentences. In yellow, the number of field goals was F equals 1 more than twice the number of touchdowns, 1 plus 2T. So I'm looking for this sentence in my multiple choices. I notice that that is backwards, so it's not number 1. Number 2 has it. F is 2t plus 1. Number 3 also has it backwards, so it's not number 3 either. And so it could be number 2 or number 4. Both of those have that same sentence, just a little bit reversed. 2t plus 1, 1 plus 2t, the same thing. As far as the other one, the total sentence goes, they scored 55 points altogether. We know that 7 points for each touchdown plus 3 points for each field goal has to be 55 points. And that, my friends, is this equation number 2, not number 4. 4 has it backwards. So we're going to solve this system and determine how many touchdowns and field goals the fabulous footballers earned last night. We're going to do this by substitution. Now, I have these two on the same page, so you might flip a little bit. If we plug in for F, 2t plus 1, we get 7t plus 3 times F, which we're going to replace with 2t plus 1, equals 55. This is not a difficult problem to solve, but we're going to need to work through the steps. 6t plus 3 equals 55. After we do the distribution there, you get that. We can combine together 7t and 6t, make 13t plus 3 is equal to 55. We could subtract the 3 from both sides and get 13t equals 52. And I believe if we divide by 13, we get 4 touchdowns for the answer to this problem. Yes, 13 times 4 is, in fact, 52. I think that works. 13 times 4 is 52. Perfect. Now, they only scored 55 points, and looks like 52 of those points came from touchdowns. So the number of field goals is, let's see, 2t plus 1. That's not right then. Did I make a mistake? Stand by. Please forward this video. I gotta think about this for a minute. Did I make a mistake? I don't feel like I made a mistake. Let's see. Fabulous footballers earned 7 points for each touchdown, 3 points for touchdown. Number of field goals was 1 more than twice in touchdowns. 17 plus. So I got 16. Oh no, I'm right. Okay, I haven't made a mistake. Sorry, I withdraw. I guess I'm right. 4 points times, oh, okay, I was doing the math wrong. 4 points times 7 touchdowns is 28 points. For some reason, I got that wire crossed with 52 points there. So the number of field goals was twice the number of touchdowns plus 1. So 2 times 4 plus 1. Looks like they scored 9 field goals, which kind of makes sense because 4 times 7 plus 9 times 3, that's going to give you the 55 that you need for this problem. Okay, moving right along. This one's going to take a little longer now because I had to stare at it for a minute. 439, yesterday Mika was given some information and was asked to find a linear equation, but last night her cat destroyed most of the information. At the right is all she has left. We had to complete a table and graph the line. Well, the good news is that we have all the information all together. Like, for example, I know from the table, well, I know from the graph that the point negative 3, 3 is on the line, so negative 3, 3 can go over there. And from there, I know that this goes up by 1, and this goes down by 2. So that's going to be the slope of the problem. M in this problem is going to be negative 2. And from there, it's actually relatively easy. You're going to go negative 1, negative 3, negative 5, negative 7, and negative 9. You could plot those points now if you wanted to on this graph. I'm only going to plot 0, negative 3, because that's the y-intercept. B is going to be negative 3. So the equation is y equals negative 2x minus 3. And you could plot any one of these points that you like, but once you have 2 points, you can just connect them into a line, and that's all you really got to do there. There you go. Not too hard to do, actually. Mika thinks the equation for the graph could be 2x plus y equals negative 3. Is she correct? Yeah, she is correct. Because check this out. If you take the equation that we got, which I guess we didn't need to do, you could add the 2x over and move it to the other side of the equation. 2x plus y is negative 3. So totally, that's a very valid thing. 440, Kevin and his little sister Katie are trying to solve the system of equations shown below. Kevin thinks the new equation should be 3 times that thing. Katie thinks it should be the other thing. Who's correct and why? Well, let's figure out what it is. We take y and replace it with 6x minus 1. So we want to replace that y down below. And that would be 3x plus 2 times 6x minus 1 equals 43. And whose is that? Is this Kevin or is this Katie? Katie. Katie is correct. That's what we're looking for right there. That's it. Yeah, so Kevin made the misconception of plugging it in for x. That's what he did. He plugged it in where x is and not where y is. That's the problem. And then 441, we got some exponent rules problems. These are just good to review every once in a while. 5 to the 0 power equals 1. 1 times 2 to the negative third. So 2 to the negative third power, honestly, is correct because this is just 1 right there. You could, I suppose, do 1 over 2 to the third power, which is 1 over 8. If you wanted to go that far, but you don't need to go that far. For question B, again, it might be helpful to multiply across all the way first. So in the first step, on the top of the fraction, you have a to the third power times a to the first power. That's going to be a to the fourth power. And you got b squared hanging out there also. On the bottom, we also have a to the fourth power and b to the negative second power. Now these two are going to cancel out because they are exactly the same. If you wanted to use your exponent rules, 4 minus 4 is 0, and a to the 0 power is 1. But the b's, though, they do not cancel out. It's 2 minus negative 2, which actually combines together to make b to the fourth power. That's the final answer. Question C, you got scientific notation. Honestly, what you should do is rearrange the parts. Put the number parts together over here, and then put the 10 to the negative third times 10 to the second power over here. I don't know what 2.3 times 4.2 is. My calculator can tell me that it's 9.66. But as far as the tens go, negative 3 plus 2, it would be 10 to the negative first power. Now, I like this answer, although I know that some people will disagree with it, but that's the answer that I'm going to leave there. Question 3.5, this is going to ask us to square this. So remember, this is 3.5 times 10 to the third times 3.5 times 10 to the third. When you square something, you multiply it by itself. So we need 3.5 times 3.5 over here on the worst one part, and then we're going to have times 10 to the third times 10 to the third. So the 10 to the third power are going to become 10 to the sixth power. That's cool. But then 3.5 times 3.5 is going to be 12.25, and I like that answer quite a bit. Now, again, I will meet some scientific notation purists that say, like, okay, this has to be in that spot. So it would be 1.225 times 10 to the 7th power, because you move the decimal point one spot to the right. I don't care. These are the same. Scientific notation is dumb anyway, but that's just a thing to watch out for. Okay, cool. Thanks for watching this video. Hey, it made 15 minutes, but it was worth it. All right, I'll see you in the next one.